Hello, my name is Victor Munoz. I'm a DevRel at Flare, and today I have the pleasure to introduce a demonstration on how you can bring Web2 data on-chain with Flare. We get a lot of questions about what is Flare and what makes Flare unique, and what are the kinds of applications that we can build on top of Flare. So the purpose of this workshop is, one, give you like a quick rundown about Flare, what is it all about and what you can do with the specific examples of applications. And then we're going to have a sort of live demo. We're going to run a demonstration of a flow that will show you how you can grab data from a Web2 API, verify that on Flare, and then perform a specific set of actions on-chain based on that. And this sort of flow is something that you can apply to many different types of applications, which is, of course, kind of up to you what you can do. So in that sense, what you can expect for today is understanding what makes Flare unique, learning the basics of the Flare data connector, which is basically an enshrined oracle that allows us to verify Web2 data on Flare, and also where to find the best information to start building. And by the way, we have quite a few of these that will give you all that information right off the bat if you want to check it out. Okay, the first question that I get from people in these kind of events is, what is Flare all about? And what we answer is, Flare is an L1 blockchain that is EVM compatible, and that doesn't really tell you much until I share that we have data protocols that are native to the chain that are enshrined, right? So if you think about, for instance, building on Ethereum, if you need any source of external data, you will need to call oracles, and that comes with a different set of assumptions regarding the security. But on Flare, oracles are part of the network, and that means that they inherit the same this level of decentralization and security. But that's not all, because utilizing these protocols, there are ways in which you can bring data and build solutions on top of that. So what you can see on the slide is an example of 3 different systems or protocols that you can utilize today and build on Flare and qualify for the bounties that we have. So the first one, and pretty simple to kind of explain, is the FTSO, or Flare time series oracles, that you see on the center. It is basically an enshrined oracle that provides decentralized data feeds to the Flare network. People use this for price feeds, right? So nothing too, let's say, impressive about that, but wait a minute, because then we have another protocol called the FTC, or Flare Data Connector, that allows you to bring data from Web2 and other blockchains to Flare, verify that, and then trigger some actions on chain. And this is precisely what we're going to explore today with a Web2 API example. Now, the most interesting thing is that when you combine these technologies, there is a wide variety of systems that you can build on top of that. And things are getting more and more exciting, I would say, on Flare because of this, with the example of FAssets. So in simple terms, FAssets is a trustless, over-collateralized asset representation for non-smart contract platforms. So think about, for instance, Bitcoin that doesn't have programmability, right? What you can do utilizing FAssets is essentially a user could lock their Bitcoin and utilize a minting on Flare that will connect these protocols via the FTC and FTSO, so that you can have access to EVM DeFi. So now all of these assets that are from other chains that are sitting idle, they can have access to EVM DeFi. And we are working towards implementing this with XRP And this has brought the word or the movement of XRPFi, in which there is a bunch of people and a bunch of developers building solutions that are going to work for XRP, and they will have like access to DeFi EVM, and there is a lot of capital that is going to be moving because of that. So you can see how you can start from very basic features from these oracles and then build more sophisticated systems. And I hope that today I can give you a glimpse about this and how you can actually implement your own solutions. So today we're going to talk about the Flare data connector. If you're curious, you can dive in right away in our documentation. I'm going to show you around as well. So no worries about that. What I want you to understand about the Flare data connector is that you can perform attestations of different types. And that means that you can grab data from Web2 APIs and verify it on chain, but you can also combine this with verification of actions that happens on other chains. Right now, if you think about I'm performing actions on chain A and chain B, how can I connect this and bring some logic into another ecosystem? It is really a complicated problem to solve, and we are providing a solution via these enshrined oracles. Now, the number one question that I get when I'm explaining about the Flare data connector is, okay, sounds good in paper, but in practice, what can I build with this? And there is a wide variety of applications that you can think of, in which, for instance, for today, we're going to focus on sort of Web2 applications, but there are also like Web3 sort of connecting with Web2 applications as well. But for the Web2 side, we can think about insurance. So imagine that you're a farmer, you have a crop, and you have an insurance. Bad things happen, the weather is not good, and there is a flood. Then you would have to go with your insurance, get a person to verify that, and go back and forth before settling any sort of insurance. When utilizing this kind of tool, what you can do is simply fetch data from weather or maybe satellite images, or combine both sources, right? And essentially settle the payment based on the fact that the data is verifying that essentially there was a flood on a specific region, right? And this can apply for all sorts of different insurance policy, and you can apply this to other kinds of market. For instance, carbon credit, you can emit carbon credit tokens, for instance, when you verify that company A is producing a certain amount of clean energy. And things get really much more exciting, at least for me, when it comes to social media and systems that will allow you to have reputation on chain, but also they bring like Web2 data, right? Because essentially you can combine those sources of data to have a system that will verify information and then trigger some logic. Let's talk about, for instance, in crypto, they talk a lot about KOLs. How effective are they? Well, there are a couple of things that you need to look at. You need to look at, for instance, what they are posting on Twitter and the quality there, then what they are doing on chain, and verifying those kind of things can be really, really kind of complicated and time consuming. So with the Flare data connector, in principle, you can build solutions that allow you to verify all of that and then trigger some logic, which in the case of, I don't know, the KOL would be maybe a payment, right? So if he performs a certain amount of posts and has certain, it is about certain threshold of reputation, then he would get paid X amount, that kind of thing. So yeah, today we are going to explore a concrete example in which what I really want you to take, if you're thinking about bringing Web2 data on chain, is the general flow of the Flare data connector. And I can tell you right away that is certainly not possible that I can explain that to you fully in details in 10 or 15 or 20 minutes. So what I'm going to do today is I'm going to explain you the general flow, such that if you are serious about this and want to get started, you know where to go and what do you need to change in order to make it work. Because we have a starter kit on Hardhat and also on Foundry that you can utilize to get started with this with a complete example and the full flow. So what we are going to be doing today is we are going to grab data from a Web2 API from a Star Wars place. We are going to perform an API call, right, and then perform some processing from this data utilizing a JQ filter, and then verifying that through the FTC server, and you will need to prepare an attestation request and validate that, and then this will be broadcasted to the network so that the validators of the network will have to vote and perform the fetching of the data and apply the same rules that you share on the script about how to go about this data. And then if it's valid, if there is consensus, there will be a proof that will be generated, right, that you can then retrieve from the data application layer, and then you will have your data that is verified and you will have a proof. So now here's when the on-chain logic comes, and you can, in this case, we're going to do something very simple. We have a list of characters, and we're just going to create a list that performs a calculation based on the properties of this character and adds this to the list, and then storage everything on-chain, right? So you will go from an initial Web2 set of data that is raw to a final list that has special components that has been verified and that has been enhanced on-chain. And that's sort of what we're going to be exploring today. So now we are going to go into the details of this demo. It's called Web2 JSON. The QR code that you can see on the center of the screen will take you to our developer guide, which is something that I really recommend you to get started with. And on the right, you also have access to the Flare Foundation GitHub. There you will find all of our repositories, including the ones that are going to be relevant for you, which is like the Hardhat starter kit, which we are going to be using today, and the Foundry starter kit. You know, you can utilize whatever you want, right? And also on the left, I prepare a sort of FTC 101, because when I was studying how to explain this, there are a lot of details that, you know, it's not easy to cover, and we are actually going to use the help of AI to cover some of the details to help us explain pieces of the code. We're going to use Cursor with a project setup that is going to be the Hardhat starter kit, but you probably need additional information if you want to change that to your specific application. Let's say you want to bring data from Twitter, then of course you will need to change things on this project, right? So how you go about it, well, I'm giving you some pointers in this documentation, and I'm going to show you around. So, okay, let's just first get a few things straight. So if you go to the Flare Developer Hub, you will find here how to get started building on Flare. Like I said, it's an EVM chain, so pretty straightforward in that sense. You have all the information about the network, the RPC, how to get started and deploy your first smart contract. Fairly simple if you have built on Ethereum, which I'm pretty sure all of you have. And then it becomes more and more interesting as you explore our different products. So like I said, today I'm going to explain an example of the FTC that we have here, but there are also other protocols that you can utilize and you can build for this hackathon, right? So you have FAssets as well and the FTC. So we're going to go here to the Hardhat guys, and what we're going to be exploring today is this Web2 JSON example. Now, before I go into this, I want you to perform the following actions so that you can follow exactly what I'm doing here and we're all on the same page. So if you go to the GitHub of Flare, you can click here on the Flare Hardhat starter, right? And it has some very simple instructions for you to just test it, right? And it's fairly simple. You just follow these instructions, yeah, right? You do the git clone, yarn, set up your M file, the usual stuff, right? So if you do that, then I am going to open up how things would look like and what we can expect from the Web2 JSON example. So what I have here on the screen is essentially the Web2 JSON example. I open this up utilizing Cursor. Why? Because what I want to do is not only run this example, but I want the AI agent to explain to me the different pieces of the flow, so that when you have to build, you know exactly what to change and which pieces of the code are relevant for you. I have about 5 more minutes, so let me get started by running the example. So you do yarn hardhat run scripts FTC example web2json.ts network custom 2, and you hit enter. Hopefully this is going to work. I mean, we have tested it thoroughly, and it has worked before, so no issues. And then what you will see is a bunch of logs that might get you confused the first time, right? So what is happening here is essentially we have the full flow implemented on one script, which is on this folder scripts web2json.ts, right? That what it does is it will prepare an attestation request that will be sent to the FTC verifier server. You will perform an API encoded request, and then this will be broadcasted to the network so that the validators will vote to perform exactly the same action as you did. So you go to the to the API of the Star Wars, you grab some list of characters, and you will tell him what information you want to process and send that, right? And then the validators will replicate that and will both reach a consensus, and based on that, what they will have there is essentially a proof that what you are sending from the Web2 side is valid, right? And in that way, the data is going to be verified. So just a couple more of words about this. If you want to check out the API, you can do it here at this website, swappy.info. And another thing that you might want to do is play with the JQ filter so that you know what are the rules for processing this data. If you have never done this before, I have tested out like very at a superficial level to play if you can do this with AI, and you can pretty much do this with agents, right, and Cursor and whatnot. Now, what I want to stress out now is in the final minutes that I have, I want to do a sort of reverse engineering thing in which we take the logs that we see on the screen and we ask Cursor to explain to us which thing happened on each step. So the whole process, I run this and I leave it there because it takes about 2.5 minutes, more or less, to complete. That means the whole process from gathering the data and getting this verified and then the contract implemented so that you get an enhanced list with information from this character will take about that time. And the final log that you can see here is the information about one of these characters that has been verified on chain, and we have added a new component here, which is called the BMI, body to mass ratio or index, whatever, which is an on-chain calculation that we are doing, right? So now let's, and this is the end of the process after we have prepared the attestation request and we have gone through the multiple steps from the flow of the FTC example. I'm not going to go into the details of all of this. I'm just going to point out what is important for you and how you can make sense of each one of these logs. And this is precisely what I did with Cursor. I asked it, okay, I run this. This is my log. I need you to explain to me step by step so that I can then modify this and utilize it with my own example. And this is the output here from this conversation. It took a little bit. It wasn't that complicated, though. And then it explains to me the first step is to request the preparation and perform the API encoding, and is sharing here what is like the terminal output that I'm seeing here. How is this related to the lines of code from the main script, the Web2 JSON here? And as you can see on this piece of code, we have all of the information about the API URL, the rules for processing this data. Now, what I would do is you guys have to first think about the solution you want to implement before you start gathering data and start filtering that and start creating your on-chain solution, right? It's better to take some time to think about this, because otherwise you're gonna, kind of waste time processing data that you might not need, right? So what's happening here under the hood is we are defining the request parameters. Like I mentioned, we have the API URL, the post-process JQ filter. You can play with this on your own. And then more importantly, the ABI signature that defines the expected data structure for your smart contract. Remember, you are gathering data from a Web2 source, and at the end of the day, what you want is that once it has been verified, the contract needs to know what information it's going to receive, right? Okay, and then, you can go over the details of how you perform the request, how you perform the JQ filter, and what is the response from the verifier, right? So the verifier will send you a log saying, okay, everything is okay, what is the status, where is your ABI encode request, and then you will move forward to submitting this request to the FTC Hub contract. So we have a contract that takes care of managing all of the things under the hood, and you don't have to modify anything here, but I'm just letting you know what is happening so that you understand how you can implement this for your own solution. So to wrap it up, I'm just going to go high level over each one of the steps. Probably you will have questions, but I will be there. My colleague Nick will be on the booth as well, and we can talk about this in detail for the specific solution that you might want to implement. So step two, you submit your request to the FTC Hub. The steps, you will do the request submission, then you will have a round calculation, and then a voting round assignment, and then you will go over the process in which the validators are going to fetch this data, vote on this, and send a proof, right? And that proof you can retrieve from the DA layer. And as you can see, the terminal output here is going to share information about the request that has been prepared, where is the voting round, and the information about the proof, right, which is what you can see over here. Okay, so now you have the proof, and then what is next? What is the next step in this? Is essentially you will deploy your smart contract. At this point, you have all of your Web2 data, the processing rules, and the verification. All of that is ready. Then what is the on-chain logic that you want to implement? You have to think about that. And in this flow, we already have a contract that is going to be deployed, and it's very kind of simple what it does, because what it's going to be doing is just grabbing some of these parameters and performing a calculation of the VMI, right? And finally, like I mentioned, you process the proof and decode the data. The terminal output that you can see here with the proof X and the response type is the same that you will find here on the logs. I know that the logs are kind of hard to see from here, so that's why I wanted to separate this with this more, I would say, easy to understand output. And what is happening behind the scenes is you will have the response extraction, and you will have the data structure definition that, again, this is something that you have to define before running all of this. And final step, you decode the proof data, and you get this terminal output here that has all of the information with the hash and the information from your request and the ABI encoded data, right? So there is, at this step, there is an ABI decoding, and finally, you have the smart contract interaction. And by the end of the day, like I mentioned, what you are doing here is just gathering all of this information and performing this calculation here, right? So you perform this calculation, and then you are enhancing the initial list from the information of your character with this new information. I think that with this, I have to wrap it up, but I'll be ready for questions outside or at the booth or whenever you're ready.